my name is Janghee, and today I'm going to be talking to you about bombs. I chose this topic because not only is it interesting, it is also a very important topic. There are two main types of bombs, nuclear and conventional. I thought comparing bombs would be a fun experience, which led me to my main inquiry question. My main inquiry question is, what are differences between nuclear and conventional bombs, and which type is more strategic? Nuclear bombs are all over the news, so you're probably aware of both their existence and potential. But have you wondered exactly how do bombs work? That leads me to my first question that I will answer for you. What are the differences between how nuclear and conventional bombs work? Nuclear bombs are, you may be surprised, is a big category. They include hydrogen bombs, neutron bombs, etc. But all these types of bombs uses a scientific property that Hans A. Bethe, a Nobel Prize winner and genius, discovered, fission. What does this have to do with nuclear bombs? Well, a nuclear bomb gets its energy from bursting the immense energy holding an atom together. In other words, releasing the energy in an atom. So when the atom, uranium-235 in this case, uranium-235 is uranium with 235 protons, neutrons, and electrons, splits, it releases energy. Then the neutrons split and go on to split other uranium-235 atoms, and so on. This is called a chain reaction. The first controlled chain reaction of this was in a squash stadium during the Manhattan Project, or the project to build the A-bombs. During this process, particles are released that are harmful. There are three main particles. The first one is alpha particles, which do really no damage. The next is beta particles, which can destroy layers of skin and do some harm, but does almost no damage compared to gamma rays. Gamma rays can penetrate skin and can mess up also DNA. This results in mutations, but no incredible health. A 450 rem dose of radiation gives a 50% chance of life or death. Roentgen equivalent man is rem. Rem is a scale to measure radiation doses. If the rem number is the same amount of biological damage will occur to the radiated person. Eventually, the atom releases enough particles until it changes into another element. For example, uranium-238 decays into thorium-234. This is called radioactive decay. Eventually, these unstable elements all decay into a stable element called lead. Let's talk about an H-bomb then. The sun makes its energy by fusing hydrogen atoms into helium, releasing a tremendous amount of energy. Scientists realized that this process called fusion could be recreated inside a bomb on a smaller scale. J. Robert Oppenheimer and many others objected, saying this would not lead to world peace but the opposite. As J. Robert Oppenheimer said, "We may be likened to two scorpions in a bottle, each capable of killing the other, but only at the risk of his own life." Oppenheimer, aka Oppie, was the director of the Los Alamos lab and acclaimed the father of the A-bombs. Anyway, about H-bombs. A hydrogen bomb puts hydrogen isotopes on the side, deuterium or tritium, ready for fusion. What is deuterium or the other thing? Deuterium is when a regular hydrogen atom has an extra neutron, and tritium is when there are two extra neutrons. These isotopes release more energy when fused because they end up fusing more neutrons together. Isotopes in overall is just have same chemical properties but different nuclear properties. Anyway, the energy released from fission causes fusion, which releases more particles that causes fission again, and so on. It is a loop of fission and fusion. Conventional bombs work in a similar way. As Dr. Veronica Delgevres, who were interviewed, told me it works almost the same, except the energy comes from chemical energy and not nuclear energy. Conventional bonds are relatively big, like the Moab here, which will be talked about later. Chemical energy is when a chemical bond of atoms and molecules, is separated by a chemical reaction, usually fire. Uranium or plutonium is held together by much more energy than chemical bonds are, making nukes far more powerful. But conventional bonds are much more simple to make. Successful chain reactions had not happened at Germany. On D-Day, an Alaska Special Ops team discovered the bomb had stopped being built. Although equipped with top physicists, the Nazis failed to build an atomic bomb, luckily. Nuclear bombs are much more powerful in pure firepower, but other areas bring it down. One such area is nuclear bombs are opposed and disliked because of their factors such as radiation. At one point, 35 million people signed one petition to ban nukes. Similar petitions across the world occurred together. Finally, in 1958, the first march took place. The march, called the Aldermaston March, started at Trafalgar Square, UK, and lasted 4 days. The end destination was an atomic weapons research establishment. The world also saw this as important and awarded Linus Pauling in 1962 the Nobel Peace Prize for working to stop the further uses of nuclear weapons. Finally, as a result of all this effort, the Limited Nuclear Weapons Treaty was signed, followed by the 1976 Peaceful Nuclear Explosions Treaty, which halted the production of nuclear weapons. During the Cold War, the number of nukes were growing to an astronomical 66,000, but today it has dropped to around 17,000 nukes, but that is still enough to destroy the world many times over. All these people don't like nukes because of their one factor, radiation. The little boy, the A-bomb dropped on Hiroshima, killed more people by radiation than by blast. The beginning stage was 1 to 9 weeks. Called the initial stage, most casualties occurred, and 10% came from radiation. And the next intermediate stage, 10 to 12 weeks after the blast, over 90% of deaths occur from radiation, and you get the point. This is the horrifying effects of radiation. Although acts against nukes are still taking place, we never know when they will actually be banned. But conventional bombs are also not popular at all. After the Moab was dropped on Afghanistan, countries questioned why the United States dropped the Moab on Afghanistan. The only answer was, we believe there were ISIS tunnels nearby that allowed them to move around freely. The Moab ended up killing 94 ISIS fighters, and there really were tunnels, but this action was criticized all over the world. We have been talking about how bombs in general work, but I thought it would be interesting to compare bombs. I will be comparing them in 3 categories: cost, yield, and size. I will be comparing the Hiroshima bomb and the Moab. Hiroshima had a yield of 12 kilotons, which is 12,000 tons of TNT. It flattened the entire city of Hiroshima, killing over 140,000 people, along with 90% of the buildings in the city. The hypocenter of the blast was an extreme 300,000 degrees Celsius. It also had a very bright light. The light bleached sidewalks all around, but nearby people acted as a shield for anything behind them, resulting in what is known as permanent shadows. All this, though, was the result of about 2 ounces of uranium-235 that fizzed. The other 140 pounds simply flew away. Facing this is the Moab. Moab stands for Massive Ordnance Air Burst, but nicknamed the mother of all bombs. In 2003, the Moab was successfully tested, the most powerful known conventional weapon at the time. The most powerful conventional weapon today is the FOAB. The Russia's FOAB stands for Father of All Bombs. The Moab has an 11 kiloton yield. The Hiroshima bomb, aka Little Boy, is a bit more powerful, but the Moab is advanced in guiding. It has both INS and GPS systems to guide the bomb. As a result, it can be dropped from extremely high altitudes. Probably if you look closely, you'll see fins that are made of steel and is in a grid shape. This controls the trajectory, giving the bomb a straight guided drop. The Hiroshima bomb had a believed price at $560 million. The Moab has a believed price at $170,000. That makes the Little Boy about 3,294 times more expensive, but the Little Boy is 2 times lighter and 4 times smaller. If you wanted to know which bomb is the most powerful, it is definitely the Tsar Bomba. Following up in second place is a mere 25 megaton bomb. The Tsar Bomba is 50 megatons. The Tsar Bomba had many names. Actually, the Tsar Bomba was nicknamed with the official name being the RDS-220 bomb. It was tested in a place called Novaya Zemlya, a windy, cold, and desolate place above the mainland of Russia, where over 244 Soviet bombs were tested. From there, windows in Finland or Norway shattered, 560 miles at max. The red point is the test site. The shockwave from the bomb instantly circled the Earth 3 times, and brick buildings 25 miles away collapsed. Let's watch a video of the Tsar Bomba. This is the equivalent of 50 megatons. The mushroom cloud, which is this, struck straight through the stratosphere as well as the mesosphere. It was 64 kilometers above ground zero, about 168 times the height of the Empire State Building. Over 62 miles away, due to the fireball here, people suffered third-degree burns. To think how intense third-degree burns are, think about that. If just 24% of your body is covered in third-degree burns, it is fatal in minutes. The Tsar Bomba was also an H-bomb, and its energy output was 1.4% of the sun's. Pressure was so immense, and when pressure is immense, there's a displacement in the air causing a shockwave, which destroyed an abandoned village like this, and also shook the camera. seems like nuclear bombs are much more powerful. For example, the B-83, a nuclear bomb, has a yield of 1.2 megatons, but is the size of only about a 21 cubic foot fridge, but heavy, inaccurate, and not the best for the future of human civilization. It seems like conventional bombs are a bit more strategic. Lastly, for my interview and site visit, I interviewed Dr. Janghee and went to West Point. Dr. Janghee works at the James Martin Center for Non-Proliferation. He was really nice and sent me an extensive 3 pages of answer along with an 82-slide long slideshow on his lecture. I went to West Point and saw a lot of items, although didn't learn as much. Probably the highlight of my visit was when I saw a replica of the Fat Man, the A-bomb dropped on Nagasaki. The real one blew up. Also, for more information, visit my blog. There are many more bombs written about, including the B-41 that never was. And that concludes my presentation.